an independent analysis of European defense capabilities and strategic policy.
The procurement of precision fire systems within the Nordic operating environment has traditionally followed a specific trajectory. It has favored strict alliance interoperability, heavily favoring platforms that ensure seamless integration with the United States logistics chain. However, the recent decision by the Norwegian Defense Materiel Agency to acquire the South Korean K239 Chunmoo rather than the widely anticipated American M142 high-mobility artillery rocket system, signals a distinct shift in the calculus of deterrence. This development forces a re-evaluation of the assumptions governing the modernization of the Swedish and Finnish artillery branches. It suggests that industrial availability and magazine depth are beginning to outweigh the theoretical benefits of platform homogeneity. The strategic implication here is not merely about one launcher versus another. It is about the structure of the defense industrial base that underpins the security of the Scandinavian peninsula. From a systems engineering perspective, the choice of the K239 introduces a divergence in the physical architecture of Nordic fires. Consider the current landscape. Finland operates the tracked M270 multiple launch rocket system, a heavier platform that shares ammunition commonality with the American M142. The introduction of the K239 into the Norwegian order of battle creates a heterogeneous mix of launchers across the northern flank. While this inevitably complicates the maintenance and repair overhaul framework, it offers specific operational advantages that appear to have driven the Norwegian decision. Note the technical differences. The K239 utilizes an 8x8 chassis, compared to the 6x6 chassis of the American alternative. In the compartmentalized and rugged terrain of the high north, where mobility in deep snow and off-road stability are paramount, the larger footprint and tractive capacity of the 8x8 platform provides a distinct maneuverability profile. Furthermore, the K239 features a dual-pod configuration capable of carrying twice the payload of the single-pod M142. In a high-intensity conflict scenario, where volume of fire and saturation capability are critical for area denial, the ability to discharge 12 rockets before reloading, opposed to 6, fundamentally alters the rate of fire. It also changes the exposure time of the crew during the critical reload cycle. Yet, the timeline of delivery appears to be the dominant variable in this structural adjustment. The United States defense industrial base faces significant constraints in meeting global demand for precision fires. Production queues extend late into the decade. For a frontline state like Norway, and by extension Sweden and Finland, the gap between contracting and operational capability represents a period of vulnerability. The South Korean manufacturer Hanwha Aerospace has demonstrated an ability to deliver operational units within 18 months. This is a velocity that Western prime contractors currently struggle to match. This prioritization of immediate readiness over long-term fleet standardization suggests that Nordic planners are placing a premium on the immediate rectification of capability gaps. It reflects an assessment that the risk of conflict requires extant capabilities, not promised ones. This forces a trade-off between the logistical efficiency of a single fleet and the strategic necessity of rapid rearmament. A critical, often overlooked component of this procurement is the emergence of a localized European supply chain for the South Korean system, centered in Poland. With Warsaw's massive acquisition of the K239 and the establishment of local production facilities for both launchers and ammunition, The logistical center of gravity for this system is shifting. It is moving from the Korean Peninsula to the Baltic Sea region. For Swedish and Finnish logistics commands, this creates a viable secondary supply route. In the event of a crisis where transatlantic sea lines of communication are contested, or U.S. production is prioritized for other theaters, the ability to source compatible munitions and spare parts from a continental partner like Poland adds a layer of resilience. This effectively hybridizes the system, treating it as a pseudo-European capability regarding sustainment, which mitigates the risk of relying on a supplier located in East Asia. For Finland, the Norwegian decision presents a challenge to the principle of interchangeable units. While the Finnish Defense Forces operate the M270, the munitions suite remains the primary vector of interoperability. If the K239 is integrated with the capability to fire standard NATO munitions, as technical specifications suggest, is feasible, the interoperability moves from the vehicle level to the ammunition level. This creates a functional interoperability, and Norwegian and Finnish units can share ammunition stockpiles, even if they cannot share spare parts or maintenance crews. However, this introduces technical risk. Ensuring software compatibility and fire control system integration between non-native munitions and launchers requires continuous validation. The divergence in platforms imposes a burden on the Joint Logistics Command to maintain parallel supply chains for vehicle sustainment, a trade-off that demands rigorous management to prevent friction during joint operations. Sweden stands at a complex decision point within this evolving architecture. As the logistical staging area for the Nordic front, Sweden is currently assessing its own requirements for long-range precision fires. The traditional impulse would be to align with Finland's U.S. origin architecture, so as to create a seamless firing line from the Norwegian Sea to the Karelian Isthmus. However, the Norwegian pivot to the K239 introduces a competitive variable. If Sweden prioritizes synchronization with Finland, the M142 or additional M270 remain the logical choice, despite the delivery delays. Conversely, if Sweden prioritizes the ability to rapidly field a division-level fire asset to protect the strategic island of Gotland and the Baltic littorals, the availability of the K239 becomes compelling. A Swedish adoption of the South Korean system would effectively encircle Finland with K239 operators, potentially isolating the Finnish M270 fleet logistically, or alternatively forcing Finland to consider diversifying its own future acquisitions. And the financial efficiency of the program also warrants analysis regarding the total cost of ownership. The Norwegian contract, valued at approximately $2 billion, implies a procurement strategy that includes significant technology transfer and ammunition stocks. In contrast, the foreign military sales model typically employed by the United States includes rigorous restrictions on technology sharing and local modification. By opting for a partnership that allows for greater industrial participation, Nordic nations can potentially integrate their own sensor networks and command and control systems more deeply into the launcher's architecture. This reduces reliance on proprietary foreign software black boxes and allows for a more sovereign control over the kill chain, a factor that is increasingly relevant as electronic warfare environments become more contested. Ultimately, the fragmentation of the Nordic Fire's architecture suggests a pragmatic evolution in alliance management. The ideal of a monolithic equipment standard is yielding to the reality of industrial multipolarity. The introduction of the K239 alongside the M270 and potentially other systems creates a resilient, albeit complex, ecosystem, where redundancy is achieved through diversity of supply, rather than uniformity of equipment. It acknowledges that in a protracted conflict, the ability to access multiple industrial bases, American, European, and Asian, may provide a more robust sustainment capability than relying on a single overburdened production line. This development shifts the burden of integration from the procurement officers to the operational commanders, who must now design fire support plans that leverage the distinct mobility and payload characteristics of different platforms, orchestrating a synchronized effect from disparate mechanical systems.